Assalamualaikum and good day everyone. My name is Khairul bin Mohd Arshad. Today I would like to do some presentation on IIE 504 project and presentation. The title is LED. Here the list of journals have been chosen based on LED. The main focus is light extraction in LED in terms of method and also material. The first journal is improving tin diode using zinc tin oxide layer. Second journal is improve the optical and electrical properties of GaN-based micro light emitting diode array. The third journal is implementation of light extraction improving of the GaN-based light emitting diode with specific texture sidewall. Let's go with first journal. Improving light extraction in light emitting diode using zinc tin oxide layer. Executive summary. In this study, have been reported that synthesis and also application on zinc tin oxide (ZTO) as a layer extraction for our LED. The method that we use for this is spin coating method with layer ZTO will form on top of ZTO. This study have been produced two type of ratio is 1:1 zinc to certenize, we call ZTO 1, and 1 equal 5, we call ZTO 2, based on the optical transmission intercharacteristic to show that ZTO 1 almost 98% and ZTO 2 almost 88% is brightness in terms of visible region. The main contribution of the improvement is reduce the refraction index on ZTO layer, which enlarge the photon escape cone and minimize the fractional reflect loss between air and GaN. Okay, let's go research methodology process flow. Based on this journal, they will have two steps of process that will be implemented. First process to do some ZTO preparation that I will explain detail after this slide. The second process is fabrication of LED AP with ZTO that based on the process flow that you can see on this slide. The first process there will be PR pattern, this means the photoresist. Second process will be spin coating that we're using 2500 rpm for 30 seconds with ZTO nanoparticle. After that, we perform ZTO2 coated on a P gun with 20 nanometer thickness. After complete ZTO2 coating, we perform ZTO coated on the ZTO2 with 80 nanometer thickness. After that, we perform the removing PR. The second last process that perform heat treatment for 500 degrees C for 1 hour. Then after last process of fabrication, to perform deposition on the P and T type with the electrode. Then after complete fabrication of the process of LED, we perform the characteristic for the wafer for optical and also electrical. Okay, let's go with research methodology in detail how to do some preparation on ZTO. The first process test will be have two metal ethanol will be dissolved on the mono ethanol lamine at the room temperature using 0.1 mole zinc acetate and also 0.15 ethanol chloride will be added into the solution and recycled separately for the 30 minutes. After ratio reach 1 equal 5 for zinc and cyanide, the amount of the cyanous chloride will be increased 0.75 mol and ethylenic acid have been added dropwise on 70 degrees C. The last process of the TO preparation, the solution has been described from the room temperature for 24 hours for the aging purpose. Let's go. This is the second step of process on this journal to do some fabrication LED with ZTO coating. You can see that this is a general process using on the photography and patterning process based on this graph. Okay, let's go this process in detail. After perform the plating or PR with photoresist, ZTO layer will be do some selected area to perform spin coating was conduct with 2500 rpm for 30 seconds using the cyanide CTO material particle. After that, the CTO2 was coating with 20 nanometer thickness on top of P gun, the first layer. Then CTO1 with 80 nanometer thickness will be coating on top of CTO layer. Then after complete this coating process, we'll perform heating treatment was conduct 500 degrees C for 1 hour in air temperature after we removing PR. The last final process that we're using for the fabrication, we perform deposition on an MP3 guide using the indium electrode. Okay, let's go for the result. Based on this journal, have some multiple steps that we done on to complete to perform the characteristic in terms of electrical and also optical. The first step that we use is a XRD measurement. You can refer that the graph has been shown here that the XRD has been used some measurement in terms of the characteristic performance on the ZTO layer using nanoparticle after annealing process. That will be coating into the soda line glass as shown in this particular graph. Based on the latest graph, last graph that we showed, based on the previous slide, they can see that diffraction peak where the observed the annealing ZTO corresponding into ZTO, including the nano crystal that will improve our emission pace of the ZTO. At the same time, also we can see the secondary visual peak originally from ZT on the corresponding associate crystal plate. And based on the below graph, you can see that the good transparency of achievement on the ZTO1 on the sapphire with maximum 98% in visible region, and ZTO2 was increased with 88%. Another method that we perform on the characteristic that we can using a scanning electron microscope, we call it SEM. We do some scanning on the methodology of ZTO layer, variation design and certainized ratio. Based on the image that we can see below, SEM shows that the surface morphology or the position ZTO layer was seen in also certainized as a below picture. Picture A to show is ZTO1 and picture 2 is ZTO2. Another method of do some characteristic, we also perform an injection current with 60 milliampere. Show that on this device on ZTO1 and ZTO2 was improved compared the reference LED. You can see on the particular graph below that ZTO2 will be more increased compared for others. On this journal also have done some comparison between lighting output with the forward injection current with 60 milliampere to confirm that ZTO1 and ZTO2 increase the output power with 34% compared with reference LED. At the same time also, you can see that the TO2 show the increasing is 11% over the reference LED. Okay, last portion on this journal 1 is a conclusion based on result and also characteristic in terms of electrical and also optical. What we can conclude here is ZTO1 and ZTO2 are coated into the LED, show the light extraction is significantly improved compared reference LED. At the same time also, the EL analysis indicate that LED with ZTO1 and ZTO2 is more better than 1.6 times greater compared with reference LED. Okay, let's go for the journal 2. Improvement optical and electrical properties of a gun based micro light emitting diode ray. First chapter is executive summary. Based on this study, the lighting output and also current density of the LED can be improved using the micro LED ray structure. Based on this study, they will have two types of ray and been introduced in this study is 4x4 and also 12x15 micro LED with 130 minus and 30 micrometer pixel size was fabricated. The advantage of the implementation of micro LED ray to perform uniform current spreading and also leading the effective current injection into the multi-conductor well. Based on the corresponding emission area, the achievement rating, the output power will be increased around 174% and 160% at the 300 milliampere to compare with reference LED with a larger size of area. In terms of the electrical properties, we can see that 12 times 15 ray show the current density will be increased by factor 2.1 compared with 4 times 4 ray and also reference LED on this study. Okay, let's go for research methodology process flow for journal 2. Based on this process flow, we will have two steps of process will be implemented during this study. First step will be preparation for EP LED structure with 5 layers. This will be a first step. Second step is the preparation of the blue microarray with ITO film. Let's go with the blue microarray with ITO film process flow. The first process will be performed MESA etching with a depth 1.5 micrometer. The second process will be deposition the ITO film with 60 nanometer thickness. The next process, annealing repeat thermal at 55 degrees C for 1 minute. The next process will perform metal deposition as an end electrode. Then after that, perform silicon dioxide precision. The last process of the fabrication of LED is metal deposition for the P electrode. Then after complete for process fabrication, the next process will be perform the characteristic device for electrical and also optical. Okay, let's go for the fabrication AP LED structure. We have the 5 structure layer to fabricate the epitaxial structure on this device. First will be 3 micro thickness undoped gun layer, 4 micrometer thickness or end gun for silicon layer, 270 nanometer thickness for multi-counterwell active layer. We have 65 nanometer thickness end gun electron blocking layer and 110 thickness P gun for magnesium layer. Okay, let's go for the fabrication process blue micro LED ray with LTO film. After we complete the AP fabrication, we'll have some reference for the LED with the largest size will be 60 times 60, 650 times 650, 130 times 130 and 30 micron and 30 micron as our reference LED. And for the blue ray, micro ray will be 4 times 4 and 12 times 12 micrometer as our micro LED reference. The first process, we need to perform MESA etching. Every single of pizza cell will be determined with a MESA etching step within the 1.4 micro. After we perform MESA etching, we need to perform ATO deposition on the P gun with the thickness 60 nanometer at the ITO using electrobeam or we call E-beam with evaporator with working pressure of 2 times 10 minus 6 torr. After complete disposition on ATO film, the device needs to perform annular repeating thermal annealing system at 550 degrees C for 1 minute in air for the P-type of contacts. After we complete after annealing, metal film will be deposited using a copper 20 nanometer and argon 150 nanometer as electron for N-type using E-beam. After complete deformation of a silicon isolation position layer with 70 nanometer to separate between P electron and also N electrode, the final process to perform N P electrode similar deposition as the N-type of electron. Based on below, you can see that the process flow of fabrication of blue microarray based on figure below. The next process that will be shown that we will refer on the result based on the characteristic and be completely on this study in terms of electrical and also optical. Based on this slide, you can see that result have been shown the electrical and also optical properties of ITO film as the thickness increased from 40 to 80 nanometer and the transmission for the ITO film on the quarter after annealing 550 degrees C for the 1 minute. You can see that all the transmission will be increased at the 450 nanometer. Based on this slide also, you can see that the sheet resistance show the dressing parallel with ITO film thickness, and the sheet resistance will be increased from 260 will reduce until 168 ohm at the 450 nanometer. That means it's confirmed that will be threshold between transmission and also conductive of the ITO depend on the thickness. The optimization thickness for 60 nanometer with 82.5%, 82.5% and 170 ohm. Next measurement on the device performance including curve, IV curve, light output current characteristic and EL spectra at 300 microampere for the reference larger LED and the 2 micro LED ray. The result has been shown electrical and optical performance of the reference larger area is better than 2 micro LED because it's highly dense on micro LED has been screened by P electrode reducing the effective emission area. In this study also, we can measure the electrical and also optical characteristic at the actual emitting area. The current density at 5 volt measurement as below. For 12 times 15 micro ray, the measurement current will be 1.94 ampere millimeter square, and 4 times 4 micro ray will be 1.02 ampere millimeter square, and the larger area will be 0.9 ampere millimeter square. With the high density and small pixel exceed the high current density by the factor 2.1 compare the larger LED. This is increase of the current attrition to reduce the current crowding effect. Another measurement that we can done here based on the EL spectra at the 300 milliampere. You can see that based on the graph below, 12 times 15 and also 4 times 4 micro ray have been achievement rate lighting output power is higher than 174 and 116% compared with reference LED. Last part for the journal 2 is a conclusion. Based on this study, they're considering that the emitting area for each micro LED that will be increased for micro LED ray is higher than CT ray with and also small pixels. The lighting output also increased 174 and 116% at the 300 milliampere for 12 times 12 and 4 times 4 micro LED ray compared with larger LED. And also, the EL spectra show 174 and 109% achievement for the 12 times 15 and 4 times 4 micro LED ray. The result will be indicator the uniformity of the current spanning was improved and the crowding impact was reduced for micro LED ray implementation. Let's go for Journal 3. Implementation of light extraction improvement of the gun-based light emitting diode with the specific texture sidewall. The first process that will be executive summary. This study showed that the comparison between different design of the texture sidewall will be a concave, pattern and also mirror angle with 15 to 90 degree with a conventional flat sidewall. The preparation of the sidewall with a concave and also concave using the intensity coupled plasma approach. The device with a 45-degree sidewall and the device with a concave sidewall to show the injection current of the 300 milliampere have significantly improved by 18.3% and 18.2, 17.3 and 60.6% in optical performance. In terms of lighting output, external quantum efficiency, wall plug efficiency, and the lumen flux compared with conventional flat wall. The achievement of the optical performance mainly contribution with to increase light extraction in the horizontal direction due to significant reduction in total external reflection at the sexual side wall. The device also can be promising for the high power current on LED application. Okay, let's go for the research methodology process flow for journal 3. The first process will be start on the fabrication LED with the structure slide grow. Second, we perform the wafer cleaning, perform the ICP dry etching. The next process will be photoresist layer. Next process will be photography side wall from the convex and concave and also the variable angle. The next process transfer the side wall using the argon plasma etching. Next process to perform deposition P-gun using the RS sputtering. And the last part of the fabrication process to perform metal deposition and also P-type electron. After that, we perform characteristic metal and also characteristic of the device for the optical and also electrical. Here, the fabrication of AP structure for this device on the journal 3. The FHC structure has been conceived with 2 micro thickness undoped gun layer, 2 micro thickness on the P-type gun silicon layer will be N equal to 160 centimeter square, 15 periods in gun for multi-contour well active layer and 0.3 thickness for pin for magnesium layer with the P times 10 power 7 17 centimeter minus 3. Okay, let's go for the fabrication of LED with the texture side wall. After we perform on the application growth and also wafer cleaning, the next process will be ICP dry etching to utilize how to define using a MESA region. After that, the next process is the photoresist layer was deposit on top of surface of the wafer. The next process, the photography will be sequentially using from the side wall with a concave or convex pattern and also variant angle with 50 degree to 90 degree with a dip with 1.2 micrometer. The next process is to transfer all the structure side wall to LED using the connect to argon plasma etching. The next process, deposition on the P-gun layer using the RS sputtering with 220 micrometer thickness NOTO. And after that, to perform the metal layer, securely deposit using the thermal evaporation for the N-type and also P electrode pad. After complete for the N also P-tap, active region in nitrogen atmosphere to improve the metal semiconductor contact characteristic. You can see that the gun LED side wall based on the angle alpha 50 degrees C, 30 degrees C, 45 degrees C, 60 degrees C, 75 and also 90 degrees C. You can see that the all device will be remaining as a below figure. Device A will be the conventional side wall. Device B will be convex side wall. Device C will be convex side wall, concave side wall. And device D into I will be variable angle 15 degrees C to 19 degrees C based on below figure and also below table. The all sample will be designed individual chip with the dimension will be 600 centimeter times 750 micrometer square. The final chip step that will be or the 3 chip will be attached onto the board sub-mount for the electrical and also optical characteristic. Here the result of the journal 3 that we can see that based on the below schematic diagram, to show the possible lighted path of the surface of the sidewall and the surrounding air into the horizontal direction. Another characteristic that we perform the result on the scanning electron microscopy, we call SEM, based on the picture A for the flat sidewall and the tilted view or SEM for the etching sidewall for the device B and also to I. The corresponding also to show that the reverse bias on the IV curve characteristic as mentioned below. The all device has a similar IV curve forward current of the study around 2.9 volt and 4.9 volt at the 220 milliampere and 300 milliampere. The all device make some uniform gun LED wafer, and because of the ICP dry etching process do not integrate of the electrical properties. Another characteristic have been performed is under injection current 350 milliampere. The LOP value of the device A until I has been shown in the particular graph. The study of the LED show that enhanced lighting power output characteristic device B on the convex sidewall and F 45-degree sidewall achieve 18.2% and 18.3% improvement. Another characteristic on the optical is a EQE have been performed on this particular device using the injection current of the 350 milliampere. You can see that the device until A do some measurement have been mentioned in this particular slides. Compare with the device A, device B and device C will be increased around 18.2 improvement. For the device B and device F is more higher in terms of the LOP and also EQE compared with device A. This is because of the significant improvement of the LOP, mainly contribution from the implementation of the station wall. At the same time, this is increasing of the scattering probability of the photon at the interval surface between gun sidewall and also surrounding air. And the injection current during at the 500 milliampere compared to A, B, and F increased from 17.7% and 16.9% for the improvement in EQE. On this slide, have been shown that the wall plug efficiency on at the injection current 350 milliampere. And the below graph also to do some measurement from the device A until device I. Compare device A, B, and F will be increased for 19.8% and 17.3% improvement on for the wall plug efficiency. The power conversion of efficiency study in device is improved. Another characteristic have been performed on this device and this study is luminous efficiency is the ratio between lumen flux and also input of the electrical power. Lumen efficiency for the device P until A as stated in this slide from 2.7 until 2.6 lumen per watt is higher compared with the flat sidewall device A is 2.4 lumen per watt. And you can see that the graph here can be devised for every single device and do some measurement in terms of the lumen versus current. Compare device A versus B and I, efficiency increased to 12.5 until 8.3% improvement in lumen efficiency. Another characteristic also that we do some measurement here is light emission image to show captured during this study at the injection current 350 milliampere. Based on the graph below, device A and device B is more higher than increase compared with device A. Last portion on the Journal 3 is a conclusion. The texture side wall with the concave pattern and varial able to prepare using the ICP dry etching during the fabrication. The LED with the structure side wall is better performance in terms of the electrical and also optical. The result have been shown already that the be approach Texas sidewall can be efficiency improved in terms of lumen efficiency, LEE, LPO, EQE, and LPE in terms of the device F and also device P compared with a conventional flat sidewall is a device A. The achievement of the optical performance is mainly contribution with increased lighting acceleration is the horizontal direction due to significant reduction in TR structure sidewall. At the same time also device B and device F is promising to use for high power gun LED application. The next slide here is to do some comparison for the all three journal in terms of novelty, method, and also result. Let's go for the journal 1. In terms of novelty, we are using the introduce a new material to be used for the LED to improve our lighting efficiency in term, for the LED performance. The method that we use for this will be using spring coating methods on the layer of the TO of in top of the LED. Then based on the result that mentioned here, we can improve our lighting output around 34% at the GTO and also 11% for the TO2 compared for the reference LED. Second journal that will introduce a new method of the process LED to introduce a micro LED in terms of fabrication to improve our optical and also electrical properties of LED. The method has been used on this journal that we're using a MESA etching, perform the ETO deposition on top of the P-gun and surface electron using the electron E-beam and annealing rapid thermal annealing and also perform the silicon dioxide preparation layer. Based on the method that we have on the journal 2, we can see that letter output will be increased 174 and 160% at the 300 mA with higher density and small pixel can be achieved higher current density by factor 2.1 compared with reference LED. The last journal on this do some comparison is implemented of the micro implemented and also fabrication of structure side wall compared with conventional flat side wall LED to improve our optical and also electrical. The planning process here that we implemented here perform on the photoresist layer, photography process on the side wall structure, perform plasma etching, RF sputtering, and also thermal reverberation. Based on that, we can see the achievement of the output characteristic. The device B and F increase efficiently with 18.2 and 18.3 compared with larger with a flat conventional flat sidewall LED. Okay, let's go for the overall conclusion for Journal 1, Journal 2, and also Journal 3. The main focus of the study is to improve the light extraction of the LED in terms of material and also method for fabrication of LED. Let's go for the Journal 1. Journal 1 to show to us the material that introduced can be improved of our process in terms of the characteristic of LED were better than reference. Journal 2 to show that introducing of the new micro LED ray with a high density and also small pixel also can be improved of the current spreading and improve the clouding effect of our LED. Journal 3 to implement the new methods of the process using the texture sidewall is better compared using the conventional flat sidewall. Is significantly improved in terms of the electrical characteristic and also optical characteristic as mentioned here is LEE, LPO, EQE and WPE, and also lumen efficiency. Okay, let's go for the last slide of this presentation is a summary. All journals have been selected for study and also investigate how to improve and also implement the new method and also material to improve the light extraction for the gun-based light emitting diode we call LED. Journal 3 has been identified as an implemented light extraction improvement of the gun LED gun light emitting diode with a specific structure sidewall has identified. Based on this study, new methods have been implemented to reduce on the structure sidewall on the fabrication of the gun-based light emitting diode LED compared with conventional flat sidewall. A few methods also have been introduced after external growth and the wafer cleaning during the fabrication to produce the texture sidewall with a concave, convex, and a multiple angle from 50° and also 90° compare and also the reference conventional flat sidewall. Based on a multiple device have been fabricated and produced, the result and the characteristics show that will be emissions and will be achievement on top of the optical and also optical performance such as lumen efficiency, LEE, LPO, LQE, and WPE is compared with conventional flexibles. Plus, the device of the sidewall also is very promising using the current LED. The method and fabricate of LED sidewall also can be highlighted and manageable for industry for future. That's it for my presentation. Thank you.